Numerical problems on Kirchhoff'S voltage law and current law. For the circuit shown in the figure, determine the unknown voltage drop V1. So here in this circuit, they have shown a single loop circuit. So in this single loop circuit, there is a single voltage source of 30 volts. There are 5 resistors, 1, 2, 3, 4 and 5. The resistance value of these resistors is not given. Voltage drop across each resistor is given. Voltage drop across this resistor is 2 volts. Voltage drop across this resistor is 1 volt. Voltage drop across this resistor we have to determine. Voltage drop across this resistor is 3 volts. Voltage drop across this resistor is 5 volts. So here a loop current is mentioned in clockwise direction. This is I. So we can apply Kirchhoff's voltage law. According to Kirchhoff's voltage law, the algebraic sum of all voltages must be equal to 0 in a closed path. So here we have a closed path. So here we are going to consider the algebraic sum of all the voltage sources is equal to the algebraic sum of voltage drops in the closed path. So how many voltage sources are there? Only one, that is 30, is equal to the voltage drops in the circuit is 1 voltage drop due to this resistor. We don't know the resistance value. Other voltage drop is 1 volt voltage drop in the next resistor. Other voltage drop is voltage drop in this resistor, that is V1, plus other voltage drop is voltage drop in this resistor, that is 3, plus other voltage drop is voltage drop in this resistor, that is 5. Therefore 30 is equal to 30 is equal to 2 plus 1 plus 3 plus 5, that is 11, plus V1. Therefore V1 is equal to 30 minus 11. Therefore V1 is equal to 19 volts. So according to Kirchhoff's voltage law, 30 is equal to 2 plus 1 plus V1 plus 3 plus 5. So 30 equal to 11 plus V1. V1 equal to 30 minus 11, that is equal to 19 volts. So in the next problem, in the given circuit shown in the figure, find current I. So this is I current, that is loop current. They have asked us to determine the loop current, and voltage across 30 volts. Where is 30 volts? This is 30 ohms. Sorry, voltage across 30 ohms, that is the voltage V across 30 ohms. So we have to determine this voltage across 30 ohms resistor and the current. So if you observe the current that has been given here, the current they have mentioned it in anti-clockwise direction. The current coming out of this source will be from the positive terminal, it will be upward. Here from this source also it will be upward. And if you compare if the current direction of this loop current with respect to the current coming out of this positive terminal of this source, both are same. The current coming out of this source, if you compare it with the loop current direction, both are opposite. That means that in the same branch, because of these two sources, current should flow in two directions, which is impossible. Therefore, differential current will flow in all the elements because of these two sources. So according to Kirchhoff's voltage law, according to Kirchhoff's voltage law, the algebraic sum of source voltages. Here the currents coming out of these sources are in opposite direction, therefore differential voltage you must consider. So 100 minus 40 is equal to the voltage drops across the resistors. So this is 8 ohms resistor, 30 ohms resistor, 2 ohms resistor. So what is the voltage drop across 8 ohms? That is I into loop current I into 8 plus I into another voltage drop is across 2 ohms, that is 2 plus I into voltage drop across this resistor 30 ohms, that is I into 30. So 100 minus 40 equal to 8 into I plus 2 into I plus 30 into I. So just simplify it, you will get 100 minus 40 as 60, I into 8 plus 30 plus 2, you will get 40. So I is equal to 60 by 40, that is 1.5 amperes. So voltage across 30 ohms is I into 30, I value is 1.5 into 30, you will get 45 ohms.